Hello. This week we're going to be talking about environmental problems. And I'm often troubled by the notion that environmental problems are something that only the rich world or the developed nations should be worried about. As Bertolt Brecht said, first comes the belly, then comes ethics. That statement just doesn't ring true for me when I see people around the world, and especially the poorer people in the world, the bottom 2 billion, where every day they're living in their environment. Every day they have to deal with water pollution that causes sickness. Every day they have to deal with air pollution that's unmitigated, that they didn't cause, they don't get any benefit from. These are environmental problems. And we're going to explore some of these problems. And again, the theme of the course is going to be that we were looking for solutions to these problems that are sustainable, that is, we can maintain them over a period of time, that they're resilient, that they can withstand stresses and respond, and also that they're just. That is, that the people that really deserve to have good living conditions get good living conditions. Now, it's beyond the scope of this course to decide whether things like clean water and clean air are rights that everybody has a right to, or is it just, or are they freedoms that somebody should have, or is it really part of just overall society's duty to provide these to people, but it's not really a right, if you know what I mean. Like, that's a very tough question. We're going to address it a little bit so you see where the argument is, but we're not going to really solve that problem because that's been going on for a long time. And this course will help inform that, but we're not going to have any solutions. So again, the topic for this week is going to be identifying problems and how environmental science can work with those.
Welcome to week 1 of environmental science. Today, I'm going to discuss the themes for the course, give a presentation, and then give you a preview of the topics we're going to be talking about in the course. For all of the other material, such as the syllabus and the grading, you should go to the orientation module, go through the material there, and then take the orientation check quiz. This material that you're going to see in this slide, too, is also just available as web pages on the D2L website. So the themes for this course are going to be that we're looking at the impact of humans on their environment as a relationship between the population, the affluence or consumption, and the types of technology that used. And this relationship is going to follow us all the way through the course. The other thing is we're going to focus more than you might in other courses on environmental conditions in communities and at the individual level, and how this could also be translated to helping out the Earth's poor who live in rural or urban areas and are directly impacted by the environment. The other thing, just as a sort of a sideline theme for the course, is that everything we talk about, you can either have too little of it or too much of it, and we're trying to find a just the right amount of development or help so that we can mitigate these environmental problems and improve the environment. So today I'm going to talk about a few things, and not necessarily in this order, but I'm going to introduce the idea of problem types, and this is the major sort of cognitive tool for this lecture, as it were. That is how we can use these problem types to identify the dimensions of different problems. One of those types of problems is a wicked problem. I'm going to look at the impact of population and affluence and technology, and use the Kuznets curve, or the richer is greener curve, to illustrate how it's just not a simple equation, but rather a more complex relationship. And then we're going to look at environmental poverty and the relationship between environment and poverty, as an example of how multiple factors contribute to environment and its degradation. And then finally, there'll be some comments on how this is all a complex system and what we can do to address problems that arise in a complex system, including how we can meet the goal of sustainability. At the end, I'm going to give a survey of the problems that we'll address in the course and how we use multiple approaches for that. So let me start by talking about problem types. And these problem types are a combination of, it's a good way to address environmental problems from the very first part, to see what's known about the problem, what is the information demand, is it simple or is it complex, and then what's the alignment between costs and values, and that could be between individuals and other individuals, or it could be between individuals and the community. And if there's a very limited information demand, that is, it's a sort of simple information demand, and there's good alignment between individuals and community, it's really an easy problem. It's called easy problem, and that could be solved with implementation of regulations or some sort of agreement. And a good example of this is getting the lead out of gasoline. It was the right thing to do. Everybody agreed. We knew how to do it as business and society. And so just to pass a law to eliminate lead from gasoline was really sort of an easy solution. We can have systems that we understand, that is, that there's a simple information demand, but there is a disconnect between the values for the individuals in the community, or individual values. And a good example of this is a common pool resource problem, such as forests or wells or pastures. In these cases, we understand how the forest or well or pasture works, but we need to deal with how the community uses those resources. So it's not a matter of having evil people extracting too much resource from the environment. It's just, if you ask an individual what his benefit is, it would be to harvest more trees. If you ask the community what the benefit is, it would be to keep more trees standing longer so that they can have clean water and get a longer-term economic development out of that. So it's just it's a difference of values between those two, and we shouldn't jump to saying one is, somebody's acting in a greedy way or something, but just that this is that's a good example where an individual versus community has conflict over values. Now, when we have more demanding information requirements, this could be a complex system. We need more information before we take action. An example of that might be when we try to mitigate for the loss of a wetland. We're going to put a road in, we're going to lose some wetland. How would we mitigate for that? Well, given the individual circumstance and what's actually being lost and what the opportunities are, this might require quite a bit more information than we have right on hand in order to solve. And so it's called an information problem. More research will lead to better solutions. Now, when we have a combination of high information demand and high uncertainty because of that, and poor alignment between values of the community or individuals versus individuals, we end up with what's called a wicked problem. And a wicked problem is not just that there's uncertainty and poor mismatch, but that these are acting together to make it even harder to solve. So as you get more information, people's values change. As you identify people's values, your demand for information changes. So it's an interactive quandary that you're in, and this leads to the idea of a wicked problem. Wicked problems can have been described by several people. In one case, just a simple category of benign problems versus wicked problems. And benign problems can be solved by analysis and policy, and you can reach a solution. Wicked problems are intractable, and they may not even have a solution, may only just be better or worse outcomes. You're never really going to be finished working on this problem. Now, Riddle and Weber identified a list of characteristics of wicked problems, as I'm showing here, and I just want to highlight several of these. One is that there's no definite formulation of the problem. No matter how you state it, you're leaving something out, and you can't just state the problem and hand it over to somebody else. So that means there's no simple, definite formulation. There's also no criteria where you would know when you were done. There's no stopping rule. So what you're going to end up with is not solving the problem, but being involved in creating situations that are better or worse, and hopefully better. And number 8 here, each wicked problem is a symptom of another problem. That's how all of these are interrelated. Everything's connected. If you do one thing, it impacts something else. You solve one problem. All you did was sort of create or amplify some other problem. So this idea of a wicked problem, I don't mean to be Debbie Downer here and say we're all stuck in wicked problems, but by identifying that it's a wicked problem, it really sets the tone that you're going to be involved in working on this problem to make the situation better. You're not trying to just come up with a solution. All right. So what are the problems we're going to be dealing with? Let's look at the basic relationship we're going to use throughout this course to describe environmental impact, and that is it's going to be a relationship between the population, the affluence or consumption, and the technology. So population is pretty straightforward. More people doing something, there's going to be more of an impact. The affluence or consumption, this is because as societies are more affluent, they buy more stuff, they have more of an impact on the environment through consumption and waste. There's very few people that accumulate a high amount of wealth and don't do anything with it. And those people might, just have money in the bank someplace. If they have gold, even then they bought something with it and they're storing it away. So that affluence or consumption go together. And then technology can be good or bad. So you can have bad technologies that cause more damage, say something like logging with the bulldozer just causes more damage in most situations. Or if you could log on the snow using a sled that's on top of the snow, that maybe that would be less impact. So again, there's a range of different technologies that are appropriate in different situations. So to illustrate this idea that that this is a relationship and not just a simple equation where you take the population and you multiply it by the affluence by the technology, let's look at what's called the Kuznets curve, or another name for this is the richer is greener curve. And this curve describes the environmental impact of a country as a function of the GDP per capita, like how much wealth the country has per person. And for poor countries, the GDP per capita, they have low environmental impact. Because people have much more localized impact on their environment. They don't have the big expenses to make large projects that do have large impact. Then as you increase, there's just more and more of that. More money means more environmental, means more consumption, means more impact. Then you get to a point where the country has enough wealth per capita to mitigate for that damage, and the curve levels off. This could be a case where you have a developed country and they're able to treat sewage and they're able to have pollution control on cars, that sort of thing. But then as you get to the richer countries, they actually are decreasing the environmental impact by spending more and creating even less environmental impact at the cost at a financial cost. But even then, they're doing that. This might be the example of, in the United States, people driving more hybrid cars to create less air pollution in the city compared to some other developed country that has a large number of two-cycle engine scooters or old diesel trucks driving around. They just don't have the money to switch over to these higher technology, cleaner solutions, so they end up with a higher impact. So that's just one example, but it shows that this is a relationship between the population, the influence in technology, not just a linear multiplying out that more population, more affluence, more technology all lead to more impact. All right, so one of the things we're going to be looking at in this course is how there's a relationship between the environment and poverty of, say, the Earth's poorest couple billion people. In 2000, around the time of the millennium, and in 2005, Jeffrey Sachs published a book about these environment about poverty, and he talks about the Millennium Development Goals that were goals set up by international organizations. And what I want to do is highlight how some of these relate directly to the environment and some are indirect. So you can see the 8 goals here. And things like goal number 4, reduce child mortality, this is directly related to environmental problems of water quality and sanitation. Combat AIDS, malaria. Malaria is directly related, again, to standing water and poor community development in a lot of places. It leaves potholes and homes that are susceptible to exposure to mosquitoes during the malaria season. And then number 7 is ensure environmental sustainability, and that's sort of an overarching one that would lead to these. So what happens with these goals is they're really all interrelated, and so in the idea of how environment and poverty are interrelated, there's a poverty trap that includes many environmental factors. So again, in Sachs' book, he talks about this checklist for making a diagnosis of what leads to poverty, and one of the things is identifying a poverty trap. I'm going to talk about it in just a second, but you can see that the key risk factors for that trap are population, sort of trends in the environmental degradation, climate shocks such as droughts or floods, disease. Often these diseases are related to the aftermath of poor nutrition or a flood, and then commodity price fluctuations that really impact small-scale farmers. They don't have money for insurance for this, and if there's a flood or drought, it wipes out their crops. So these are all things all interrelated to the environment and the population and what technology they use. And to discuss this idea of a trap is a poverty trap is when you're in a particular situation in which your income in the future is less than your income today. And the reason for that is you're having to spend current assets in order just to make it through today or this month or this year. It doesn't have to be exactly on a daily level. So this idea of a poverty zone in which people's income in the future is less than their current income. So the reason that is, again, they're making money right now, but they have to spend it. They have to spend their money now in order to just get through today, and they don't have anything to invest. They're not going to be able to have even the same income in the future. And we're going to look at a couple of these poverty traps later in the course, and we're going to use a systems description in order to get at that. And just as a preview of that, here's a systems-based discussion of the downward spiral that is called the nutrition-based poverty trap. People need to earn money from work, and then they spend the money on food. They use the food to eat to just maintain their current health, but also they need extra food to be able to work hard. Well, if they don't earn enough money to buy the food, then they have less food, then they can't work as hard, they have less money. It becomes a downward spiral. That's the sort of systems view of this trap. It's a downward spiral, and we're going to see, I'm going to come back to this later in the course, but malaria, where you have sickness interfering with the workforce, and the population growth, we're going to talk about that next week, and demographics, that's also a downward spiral, where more population means less wealth per person, which means less opportunities. Now these systems that we're talking about here are complex. And complexity is the situation when we have multiple independent but interacting components, and as they interact, there's a whole variety of different outcomes that can come about, and you can't always necessarily predict the behavior of the overall system just based on what you know about the individuals. And this is going to come back in the course over and over again, is that these complex systems are unpredictable, and therefore we need to address them in a different way than we would if we could just identify all the factors that are leading to the outcome. So let's look at the goal of improving the environment. And one of those goals is to create a sustainable society. So when we say a sustainable society, and this was in the Millennium Development Goals, we have a steady state for resource use. We have social and environmental justice. We also want this to be an economic system that has opportunity and leads to prosperity, not just a dystopia where everybody goes back and lives in a cave and shuts off everything, but really a vibrant social and economic future as well. And we want this to happen in perpetuity. Well, with complex interactions, what we have is the potential for emergent behaviors. And that means that you can't predict the behavior of the larger system just from the behavior of all the interacting components. So a good example of this is ant colony. You can't describe how an ant colony works unless you understand, just from knowing about individual ants. You have to put those ants in a colony, in their environment with food, and then you get to see how the whole thing works. So there's inherently different and qualitatively different behaviors at the larger scale than there is at the smaller scale. And the implications for that is that if we think about sustainability as being an emergent property, then we have to deal with is create underlying mechanisms that are sustainable. Every little part has to be sustainable. Every individual, every business has to be responsible. And then we need to promote interactions and social and economic interactions that help promote that sustainability. And those are things like open flow of information and transparency, trust that we're going to be doing the right thing in the future, and then the ability for the organization and the society as at large to learn. And then it may lead to sustainability, but it's not guaranteed. You can't say, here's the behaviors that are guaranteed to lead to sustainability. It puts you that then sustainability may emerge. Well, this is this shouldn't be depressing. What it should mean is that we're going to have to focus on the individuals. How are individuals and businesses, what is their role in order to lead to this overall sustainable society? Not just what are the laws we can pass that make sure everything's going to be sustainable. That just, in this view, where society, environment, and economics is a complex interaction, we can't do that. We have to identify these the roles of individuals. So, what are we going to do in this course? Well, we're going to be looking how environmental science leads to that. What can environmental science contribute that would lead to a sustainable society and improvement of the environment? So what environmental science can provide is a open platform for people to talk about the facts and discover new knowledge and do this in a way that's rigorous and tested and transparent. Everybody knows what's going on. They can challenge the assumptions. That's the process of science. And so by doing that, it's not that environmental science is going to solve the problems, but it sets up the dialogue and sets up the information necessary for management and policy to move ahead and work on these issues. The other thing that environmental science does is we can tune the type of science we use to different scales. So, for example, at a small scale, we can use traditional scientific methods to test for problems test for pollutants or toxins in the water. That's a good environmental toxicology type approach. At a larger scale, we can use sort of management approaches to detect possible problems, like employing the precautionary principle, or using management techniques that look for likely outcomes and then constantly readjust. At the community scale, we can bring in we can address the uncertainty and bring in community partners using what we call Mode 2 science to address that uncertainty directly and say, this is how we're going to have to proceed given this amount of uncertainty. And then finally, environmental science is pragmatic and it requires some action. We're going to work with partners from different domains in academia and different sectors of the economy, that is like the government and nonprofit and businesses, to actually approach these problems. And that's what we call transdisciplinary science. So in addition to looking at these scales and doing all this, the other thing that that I'm going to explain in this course is how with science we intentionally look for alternative explanations. And so the way we're going to do that in this class is by intentionally employing multiple perspectives. I'll show you what I mean by that in just a second, but these multiple perspectives are the reason we need to look at a problem intentionally and go out of our way to find these different approaches is so we don't miss some sort of viewpoint, or we don't overlook some sort of time or distance scale, or that we can use those different approaches to discover new types of information and bring those all into the problem. So this multiple perspective framework is to consider more viewpoints, to force us to use different cognitive tools to look at the problem and discover new information, and to use those new approaches we came up with in innovative forms to address the problem. And also, the more cognitive tools we use, like in science, the more we're able to connect with multiple value systems. Okay, now I'm going to come back to that in just a second. I want to show you a preview of the material, of the problems we're going to address in this course, and then I want to just go through the list of weeks in the course to show you how we're going to use these different approaches. So we're going to be talking about population, the population amount, and how countries control their own population, which is called the demographic transition. We're going to look at environment and healthy population, like I mentioned before, with malaria and other traps. We're going to look at energy use and the different impacts on society. We're going to look at water use, the direct use, and then that's embedded in consumption. We're going to study agriculture because it's really the nexus of land and food and energy, all those things coming together, all those potential problems, and local agriculture can really help us overcome some of those problems. And along the way, we're going to make some comparisons to urbanization, how local agriculture can help in cities, and what are the sort of technologies that are better in urban centers versus rural areas. Okay, now what I want to do is talk about the list of topics in this course, and I'm going to do that by going through the sort of table of contents for the whole term. In these two columns, this is the problem-solving approach, or the cognitive tool, and then here's the example that we're going to use. So today we talked about problem types as a cognitive tool. Looking at problems, sorting them into these types helps us figure out what we're going to need, what combination of information and values we're going to need to employ to address this problem. And we looked at that sort of with technology implementation. Next week, we're going to look at stock and flow systems, and that's how those relate to the population growth and the demographic transition. Week 3, we're going to be talking about scale, and we're going to apply that to energy use at the global, national, regional, and home levels, and what different insight do you get by looking at it at each of these different scales. Week 4, we're going to be talking about optimization and how we try to improve the efficiency, and the example is going to be cooking stoves. This may seem a little mundane, but the global energy use of many people in the world use wood-fired cooking stoves. This leads to deforestation of their local areas and also a lot of air pollution in their homes, and right near the cooking area it leads to respiratory ailments. So it's a good example of more efficient cooking stoves would decrease both of those environmental and health impacts. And then we're going to have a couple of weeks talking about accounting. In one case, we're going to account for water use and embedded water in products. So for example, a liter of beer takes 1,000 liters of water to make it. So that's embedded water. You don't drink 1,000 liters of water, but it took 1,000 liters to make that 1 liter of beer. And then another one is accounting for things like carbon in the forest. We can grow trees to take carbon out of the atmosphere, but how do we account for eventual logging? What if there's a fire? These are accounting problems, and we can address that. It's one of the underlying processes of trying to identify environmental damage is to account for everything that's involved. Week 7, under integrative solutions, we're going to look at local agriculture. This is where really you bring together the energy use, the land use, the water use, the health impacts, and bring all that together, and it all comes together very, very clearly with local agriculture. In week 8, we're going to shift gears a little and start looking at ways we can try to engage with problems, and one of those is by identifying worldviews. That is, worldviews are a coherent set of cognitive tools and belief systems that people have, and how we can use those worldviews to generate scenarios, and how we can use scenarios to look at possible implications of environmental impact in the future. We're going to look at a couple of examples of population growth and global climate change, and also a very sort of smaller scale example of how worldviews would lead to different outcomes for lake restoration. In week 9, we're going to look at multi-criteria negotiations using the example of coastal development, where you have economic development at odds with environmental protection and how you can work through that. And then we're going to look at environmental entrepreneurism with the examples of providing water pumping for local agriculture, purification of water, and a few other small examples to show the power of how entrepreneurism can get environmentally friendly solutions in the hands of people across the world, probably more rapidly than any other approach. And in week 10, we're going to come back and look at scientific evaluation, which is to review the underlying models and assumptions we made in any of these environmental examples and see how they hold up. And so, for example, how would you scientifically evaluate population growth as it relates to local agriculture? You know, you're bringing in several different types of models. How do you compare those? So that's the end of this week's lecture. What I expect you're already doing is working on the material. Just go to the D2L page and work your way through the other reading. You can revisit these notes, and then you have 3 assignments due. You have the checklist quiz from the orientation, you have the concept quiz from Unit 1, and the crux questions from Unit 1 also. Good luck.